Welcome to the WEB.BM instructional video. In this video, you're going to learn how to create projects and project components such as nodes, channels, how to connect nodes and channels, and how to enter time series data such as runoff, evaporation, precipitation, and water demands. The entire video is based on using the numerical example from the WEB.BM user manual, which is a very simple system that you see here in this sketch. It has 3 river reaches. One is right here upstream of the reservoir. There is one reservoir. There's one more river reach which acts as a spillway, and there is a final river reach which acts as an environmental flow channel. There's one hydropower plant, 2 diversion canals, 2 irrigation blocks, and 1 return flow channel. The objective of this run will be to find a set of reservoir releases through hydropower plant and irrigation canals for the 12-month period, such that we best meet the environmental flow targets and irrigation demands. What are the constraints? Well, first of all, it's mass balance at nodes, net evaporation on reservoirs, equal deficit sharing in all time steps among 2 irrigation blocks, if there have to be deficits, and maximum flow through the turbine as a function of storage levels. Pay attention to this net evaporation on reservoirs constraint. It's not an easy constraint, because we are solving the system for all 12 time steps, which means that we don't know the storage at the end of every time step. And reservoir surface area is a function of storage. So that area is not known ahead of the time. In other words, this is a dynamic constraint which has to be built into the model. It's also a non-linear constraint. If you look at this system as a very simple sketch, here we have the initial volume, we have the inflow in the first month, and at the end of the first time step we're going to have the ending volume, which will automatically become the starting volume for the next month, and so forth. We're going to extend this. In this sketch it's only showing the first 3 months, but effectively the model will solve the network for all 12 months. What this will give us is the best rule curve. The rule curve here is the output from the model, not the input. And if we add one more constraint, which we are adding in this particular case, it's called the equal deficit constraints, which makes sure that supplied and demanded amounts for each of the blocks has the same ratio between the blocks and for all time intervals. Then the model will both determine the best rule curve and the best level of demand hedging for the entire year. We are now going to log on to the system. This is done by typing www.riverbasinmanagement.com. You'll get this entry portal, which if you had never used before, you're going to have to register. To register an account, all you need is your email. Once you click on the register option, you will see that you need to enter an email address and the same password twice. This can be your email address or some other Gmail that you set up only for the purposes of using this program. If you're using your email address, you can use some different password, not the password you normally use for accessing your email. Once you click on the register button, you're going to get a link in your email which you have to click on in order to activate your account. Since I already have an account, I'm going to go back to the login option here, and I'm going to log in with one of the accounts that I have here. The first time you log in, you will realize that your project list is empty because you haven't created any projects yet. If somebody sends you a project that they want to share with you, you can use this restore button, and then you'll be asked where the project is. You'll be able to find a file. It's a zip file. Click on this option to overwrite the existing components, and then just click on the upload option. The choose file essentially will open a dialog box which allows you to find your zip file that you received from another person. The first thing we need to do is define a project, and that is done by adding a project. So click on the add button. We're now going to enter the project name, which is going to be Bargy Reservoir System. I'm just going to copy this from the manual. Everything that I'm doing here is already in the manual. The project starts on the 1st of July 2008 and it ends on the 1st of July 2009, so it's exactly 1 year. The input data that we're going to be reading from the database is going to be on a monthly basis in this particular project. Otherwise, we can have an option of daily, weekly, or custom as well. We're going to save changes now. This will have created the project definition. You can add additional projects, but they cannot have the same name as this project. So the next thing we need to do is specify the components that will form this project. And this is done through data maintenance menu. The best way to start is by creating nodes. We have three types of nodes here: reservoirs, consumptive use, or junction nodes. The simplest ones are the junction nodes. We're going to add a junction which will be called Bargy Reservoir Inflow. That is the most upstream junction node in the system. We have to put some description. Once we enter it, we need to save, as well as one more node. This node in the manual is called node 7, and it's the most downstream in the system. We've now entered all junction nodes. We're going to enter reservoir node. The name of the reservoir is Bargy. You can just say Bargy Reservoir and save. Now, reservoir is a complex structure which, if you click on this button here, opens up another 4 buttons, and one of them is the storage capacity. Click on the storage capacity, and if you know when the last survey was done, that's great. But if you don't, you can just leave the default date 1st of January of 1900. And then copy the elevation, area, and volume. So these are 3 columns from your spreadsheet, and click on the paste button. Once you've done this, you need to click on the save button. We have 2 consumptive use nodes. One is going to be called Bargy Left. This is an irrigation node. For irrigation, you have an option to specify the irrigated area, which is not going to be used in the calculation if you're using cubic meters per second as the unit of measure. However, if you're using millimeters, there's another option here. Then you will need to specify the exact amount of area. The land use factor by default is 1, although if you are looking at planning to increase irrigation in the future, you can use 1.1, 1.2, which would increase the demands by 10 or 20%. Click on the save button, and then we've just created one irrigation block. We're going to add another one, and we'll call it Bargy Right. Again, land use factor is going to be 1, and the unit of measure will be cubic meters per second. So this completes all our nodes. We can now go back to the project form. Now click on the project, and you will see all the nodes in the database. These are all the nodes that we need for this project. So we're going to include them in the project by clicking on this check box. Hence, this project has a total of 5 nodes. 2 of them are junction nodes, 2 of them are consumptive use nodes, and 1 is a reservoir node. Next, we're going to specify for those nodes some time series that are required for model to run. So let's go back to our node list. In the case of junction nodes, this reservoir inflow node has some natural flows coming in. You will see that we've already included this node in the Bargy Reservoir System project. Now we need to specify when the time series is starting, and it's going to be 1st of July 2008. We're going to be entering monthly data. We're going to be entering inflows. Again, this data is all in the manual. So what you need to do is copy the 12 values from the spreadsheet or from the manual, which is a Word document, and click on the paste room. Once you clicked on paste, you need to save the data. So we've just entered inflow into the system. We then have consumptive use demands. So there is Bargy Left demand, and that will also be entered through this water use button, which has a similar form where we have to specify when the data start. So again, it's July 1st, monthly data, paste, save all, and we have to do the same thing for Bargy Right. So again, 2008, July 1st, monthly data, and Bargy Right irrigation is again in the manual. Save. And if you want to make sure that you did save, you can open again the previous form to make sure the data is visible. We also need climate stations that contain evaporation and precipitation for reservoirs. So we're going to go into the data maintenance menu and click on climate stations. And you'll find that these stations have already been created. Again, they were created by using the add button and by specifying the station name. The climate stations are distinguished as being either precipitation or evaporation station, which you can select in this box. You need to put a unique name for the station and the description. Latitude, longitude, and altitude are optional. Once you have the climate station entered into the system, you can click on the climate data. And in the same way that we entered data for the other two components, we are going to copy from the manual starting from 2008, 1st of July, 12 values, and these are the 12 monthly values. These values are all in millimeters. These are values for evaporation, and these are values for precipitation. You could have alternatively imported data from Excel if you had one column ready, and one column will be required for a month, week, or day option. But if you're using the custom option, you also have to specify the length of each time step in days, in which case the model will expect two columns instead of one. Now the climate stations have been created and they contain data, but our Bargy reservoir doesn't know that these stations exist. What we need to do now is we need to link the reservoir to these particular stations. The way to do this is to click on this green button next to the reservoir and then click on the net evaporation button. And now we are going to see this form, which basically allows the model to add any one of the climate stations in the database to a particular reservoir. In this particular case, we have two stations. One is Bargy evaporation and Bargy precipitation. When we are selecting the station, we also need to specify the adjustment factor. Adjustment factor is essentially adjusting the values in the time series. If the station is right on the reservoir, you should use adjustment factor 1. It is essentially 1.0, but if there needs to be adjustment for elevation, because the stations may be at different elevations and slightly further away from the reservoir, you can use 1.1 or 0.9. In this particular case, we're going to use 1 for both. So we save changes, and then we add another precipitation station. Again, we use the adjustment factor of 1, and we save changes. You could have specified 1 without 0 here. It is essentially taken as a decimal number. We can close this now, and that is basically our specification that links the stations to the reservoir. Once we created all our nodes, we need to move on to the creation of channels. We go back to the data maintenance, click on the channel option, and we're going to see a channel list, which in the beginning is empty as shown here. We click on the add button, and now the channel form is a little more complicated than the nodes form. We start by putting in the name of the channel, and we need to also put a channel description. This channel is of type river reach. It's the upstream inflow channel into the Bargy reservoir. Its upstream node, therefore, is going to be Bargy reservoir inflow, which is a junction. Its downstream node is going to be the Bargy reservoir. You can see this from the schematic, which you should usually draw on a piece of paper before you start creating components. After you have done this, if there's nothing else to enter here, we're going to click on the Save Changes. So we've created the first channel. The second channel is also going to be a river reach. We'll call it Bargy Spillway, and we'll have to give it a description. Let's give the same description that was given in the manual. Again, it's a river reach. It's going to go from Bargy Reservoir to node 7. Again, click on the Save button. The next channel is going to be called Bargy Hydropower. So the description is that this is a hydropower plant below Bargy Reservoir. It is located on a river reach, so we'll leave the river reach as such, although it could also be a diversion canal here in this selection. The same upstream node, it's the Bargy Reservoir, and downstream node is going to be node 7. Because there is a hydropower plant located here, we have some additional information to enter. The rated power of the plant, hydropower efficiency. This is for both the turbines and the generator. The headwater elevations, they are given by the elevations of the Bargy reservoir. So we have to say here that the upstream reservoir that will govern the headwater elevation is the Bargy reservoir. The tailwater elevations, we're going to use the constant level of 370 meters. We also need to specify one more piece of information here is there's going to be a limit on the flow through this channel. These limits will be dictated by the reservoir elevations, and we have to say here which reservoir will dictate them. And this is going to be Bargy reservoir. Again, save. And now that we're here, when you click on this green button, you will see that the outflow capacity in this particular case is going to relate elevation in the reservoir to the maximum outflow. Again, this is copied from the manual. You have to save. This looks like an orifice outflow curve. We can take a quick look at it. It is right here, and this is about this is approximately what it looks like. We are limiting the outflows to 218 cubic meters per second, which is the maximum flow through the turbines. But because the elevations are not going to be above in this example, we don't have to worry about the shape of the curve above this level. The next channel that we're going to put in is going to be the downstream river reach, which we call Narmada River. This is the most downstream river reach, and this is also our environmental flow channel, which is the way we're going to describe it in the description box. Again, it's a river reach. It goes from node 7, but because this is the most downstream channel, it doesn't have a downstream node. When we leave the downstream node empty, when we leave this box empty, it really means that water leaves the system through this channel. Again, save changes. The environmental flow targets, by the way, will be specified in the scenario, which is explained in a separate video. Finally, we have a few more channels here. We are now entering the diversion canals for supplies to the irrigation blocks. So one is called Bargy Right Canal, and it's not a river reach anymore. Now it's going to be a diversion canal. And you can see the form automatically reduced in size. The upstream node is going to be the Bargy reservoir. The downstream node is going to be the Bargy Right irrigation block. We're going to save this connection, and we're going to add one more channel like this, which is called Bargy Left Canal, with a description that this canal is irrigation canal on the left bank. Again, this is a diversion channel that starts from Bargy reservoir and flows into the Bargy Left irrigation block. Save changes. And the final channel is the only return flow channel that we have in this example. We are going to specify its name, its description, and you will see this form further reduced when we click on the return flow. It becomes actually very simple. This is a return flow from Bargy Left irrigation to node 7. And now we are being asked to specify a recorded flow station from the list of recorded flow stations that contains the return flows, or as an alternative, we need to specify the percentage of consumptive use that will be returned back to the stream. In this case, we're putting down 10% or 0.1. With this, we have completed specification of the channels. There is now one final thing we need to do to complete the definition of the project. Our project doesn't know that these channels should be included in the project. So, click back on the project form, select the project, and just like we've done this for nodes, we will now have to select the channels that we want to include in the project. Here they are. These are all the channels we created, and we need them all in the project, so we're going to click on the checkbox. Don't forget to scroll down to make sure all channels have been included. And this now completes the creation of the project. What we need to do next is define at least one scenario for this project, which we're going to do in the next video. And after that, we can go into the solver option, run the model, and enter the reporting tools option where we're going to look at the results of the model.